you guys remember from last year that if two things are similar, they are proportional. And you like proportions.
Does that say at the does that say equals or is it
okay.
like the approximate thing?
And you guys did this last year. You don't remember it maybe, but proportional means the sides are proportional. Cross, multiply, and divide, right? Remember that? Did it 100 times probably. But the angles are what? Angles are congruent. Proportional means they're the same shape, but different sizes. Okay?
What is the symbol between triangle ABC and triangle?
Same shape,
You can read that from there.
different
I can read it, I just can't see the symbol. Like
size.
It's really hard to read.
So I look at these two triangles. Are they similar? Let's see. Angle B is congruent to angle D, right? Because they're both 42. And, well, what about over here? What's F? We're going to have to figure out a missing angle, aren't we? Figure out this missing angle for me. What is it? Okay, 42 plus 80. And then subtract that from 180. What does it end up being? 58. So, what did that just tell me? That angle C is congruent to angle F. Do I have two angles? Yes, that's angle, angle, similarity. Now, the question came up, what about this angle here, A and E? Well, yes, they're automatically congruent. But the minimum amount I needed was 2. So I could say, yes, these are similar by angle, angle, similarity. So these two triangles are similar. Are they the same size? No. But they look the same. Here, I tell you what, let's do the last step. You remember on congruence, we always matched them up. Triangle A, B, C is similar, that's the similar note, to triangle, match them up. What matches A? No, that doesn't. Oh, I'm sorry, I did say A. I'm sorry. A and E, you're right. E, sorry. E, D, F. You're right. I'm sorry. I got mixed up. So, I'm looking for two angles. Do you have two angles?
Yeah, they're vertical.
Okay, yeah, I see the vertical angle. Several of you point out the vertical angles right here and right here. Okay, so let's write that down first off. Remember, we want to be thorough here. So that's going to be angle QXP is congruent to, doesn't quite fit here, NXM. Okay, so there's one angle done. Now, is there another one? Someone said something about a Z? All right, you see the Z right there, and you're right, the Z tells us about alternate interior angles, doesn't it? So, I'm going to rewrite this a little bit, but I definitely have alternate interior angles here. So I can say angle Q is congruent to angle N. Is that enough?
Yes.
Yes, these are angle, angle, similarity. Now, if you needed to, could you tell me about these other two angles?
Yes,
Yes, you could, but I don't need it. I only need two. Angle, angle, similarity. Match up the triangles, please. Triangle P.
Okay.
How about P, Q, X? Now you match.
NXM.
I disagree.
N,
M first. M, N, X is what's going to match. You noticed right there, looking at this example, it looks like these two match up, and these two match up, and these two match up. Am I right? Okay. But I need to know the ratios. What is the ratio of AC to CD? It'd be 6-4, right? Which reduces down to 3/2. All right. What about the ratio down here at the very bottom? I have BC over CE. What is that ratio? 7.5 over 5. That's going to reduce. What is that? Is it also 3/2? It sure is. So are those two the same? Yes. Now I still have to do, that's only two sides. I have to do all three sides. Okay? Now, do these two here. So I've got to do A. Let me do it on the other side. If I have room, yeah. AB over DE is 9 to 6. What is that the same as? So were they all the same? All right, so are they proportional? Yes. So how would I say, or what would I say about these two triangles? I would say, okay, let me change colors here, but you're right. Triangle ABC is similar to triangle, match them up. Okay, DEC by what? Side, side, side similarity. Okay, you just showed that all three sides are proportional. Now that takes more time than congruence, doesn't it? Okay, because you have to show all those ratios. We'll check out this other triangle off to the side. This one's interesting. Do you see two triangles first off?
Yes.
All right, make sure you see two triangles. You've got the small triangle, and then you have a bigger triangle. Like that, right? Okay, so you see two triangles. All right, let's measure up the sides. What do you think MN is going to be correspond to? MN corresponds to which side? MR, I agree. MR. So tell me the lengths of that. That's 10 over 25. Very good. You put those together. That's 25. And 10 over 25 is, what is that, 2/5? All right, so 2/5. And that's perfectly fine. You did a decimal 0.4. You could do all yours in decimals. That's fine. All right, so that's MN. Now I got to do the other side. What about MP? So MP corresponds to MS, right? So what do I have there? 12 over 30. What's 12 over 30? It is 2/5. So far we have a match, don't we? Those two match. Now, to do side, 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 I would need the bottoms here, right? I don't have them. How could I use side, angle, side? Where does the angle happen? In between the two sides. Look at angle M. Exactly right. Angle M is the exact same angle in both triangles. So obviously it's equal to itself, right? So I can say angle M is congruent to angle M. And even though I have this slightly out of order, how are these two? All right. I would say, very good, that triangle, let me find a little room here. Triangle MNP, that's the small one, is similar to triangle, do the big one, MRS by what similarity? Side angle side similarity.
3/2.
All right. Look at the first one. Are they proportional? What do you think matches?
3/4.
PR matches what?
PR matches
RT, that would be 4 over 6, which is 2/3. And then QR over RS is 2/12. What do you think?
It's PS and all.
Oh.
Yeah, it's PS and PR.
When I first look at this, they do not appear to work, do they? But you know what? We matched them wrong. Instead of matching it the way they did it, let me do this a different way. They actually match PR and RS match. So let's try it this way. PR and RS, or actually it would be SR, I suppose. That would be 4 over 12, which is a third. And what about QR and TR? That would be 2 over 6, which is also a third. So they were proportional, weren't they? What happened was these triangles got twisted. All right? They got twisted. Okay, and when you add the vertical angle in the middle, which is, what is it? Oh, yeah, sorry. All right. Side, side, and then the angle in the middle. So this is side, angle, side, similarity, right? What about over here? Are they proportional?
Side, side, side. Because my 3, 4.
Try it. What matches AE?
AC.
I think it's probably AC. We'll try it. That's 9 over 12. 3/4.
And then
What matches AF?
oh, crackers.
AB, which is 10 over 15, which is...
2/3. They're not similar.
So right now they appear not to be similar, right? Is it possible that I got the order mixed up? All right, we can try it, but in this situation it won't work. So we're going to have to say no here. All right, unless I reduced wrong.
What did you write?
Same spot. So here's the shadow of the building, maybe.
Use
They
a
would-
little shading tool.
Okay, they would both end up at the same spot. Okay, now, do you see two triangles?
Oh, yeah, yeah, yeah.
There's the building,
The building.
there's the person.
What? Oh.
Here's the building,
Oh.
here's the person, here's the sunshine.
You know what that is? I think that's something.
Are these two triangles similar? Why?
That's what the sun does. The shadow.
Okay, hold on a second.
I know.
They are both 90 degrees. So that's one angle. And they both share this same angle in the corner. What's the similarity? Angle, angle, similarity. That's very important because these types of situations come up all the time. Guess what I can now do? The distance. I can measure my, I can measure my own height, right? That is easily measurable. I can measure the length of the shadow from where I'm standing to wherever the end of the shadow is.
Actually, you could, but
Somebody else could, or I could mark it with chalk or something. And actually, I could measure the length of a shadow on the ground of a tree, or a building, or a flagpole, or something very tall.
trees over there.
Okay? And I could use those to help me find the height of something that is very tall and very hard to measure on its own. So I can use angle, angle, similarity to now show that two triangles are similar, and now I have proportions. My height is proportional to the building height, and that's where we're going to go with this.
No,
Angle, there's an angle.
The most popular one is always going to be angle, angle. What are those angles? Vertical angles. And then you've got a Z with your alternate interior. So you have angle, angle, similarity. So you automatically know these are proportional.
Wait, where's your similarity?
Oh, and then you got something for angles.
Do you see the Z?
That's the similar. Where's? Oh, so
Vertical.
It's two separate angles.
Yeah, those are vertical. Oh, you're right. Those should have been double marks. Sorry. They should have been double marks. All right. So I now know that my triangles are similar. Yay. Now I need to write a proportion. So write a proportion. What matches RS?
Where's our?
UT. That is going to be proportional to what matches RQ? TQ. Now, fill in what you know.
4 over 10.
All right. 4 over 10 has to equal
X plus 3.
x plus 3 over
2x
2x
plus 10.
plus 10. Now, I didn't pay a whole lot of attention to this. I hope this isn't too awfully difficult. I don't think we're too bad. How do you solve a proportion? Cross multiply. Yay. So we're going to solve this. Let's see. That's a little distributive property, right? 10x plus 30 equals 8x plus 40. This will work out well. If I subtract the 8x, that's going to give me 2x plus 30 equals 40. If I subtract the 30, that gives me 2x equals 10. So x must be 5. All right. So I did find x. I used my algebra to find x, but that's not what they asked me. They want to know the length of QT, so I look back here. QT is 2x plus 10. So it's going to be 2 times 5 plus 10. It's 20. So my answer is 20. Okay? That's how you're going to use proportions.
Okay. First thing we notice on this first example with the person in the tree is we want to establish if we've got similar triangles. And I can see that I have one triangle with the tree. I kind of missed that a little. And then I have another triangle with the person, and they are similar because they both have the right angle here. I know I missed this picture a little bit. And then they both share this angle. So by angle, similarity, they're both congruent. Not congruent, excuse me, they're both similar. Now, knowing that they're both similar, I can set up proportional sides. The person's height is going to be proportional to the height of the tree. So that's going to be 6 goes to the height of the tree. The same as the shadow of the person is going to be proportional to the shadow of the tree. Notice that I have to match person to person, tree to tree. So that gives me 10 to 60. And at that point, I hope it's easy to see that you can cross multiply and solve. That's going to be 10h equals 3600, and the height of the tree is 36. Okay, the second example with the tree and the stick. Notice that these two shadows don't overlap each other, so it makes you a little curious about it. But if I go ahead and recognize that I do still have right triangles. Now we have to understand that on this picture, two-dimensionally, this does not look like a right triangle, but three-dimensionally, there is a right angle right here. Okay, this angle is coming towards me a little bit, so imagine this in 3 dimensions. So I do have a right triangle, and then of course the stick does the same thing with its shadow. So it's clear to see that I have one, they both share a right angle. So there's an angle. Now I'm curious about another angle, and that what we end up finding out is by science, the principle, the angle of the sun down here is the same for both of them, because this picture was taken at the same time of day, so 93 million miles away, the sun is at the same angle. So this angle and this angle are the same, so once again, angle, similarity. That's important because at that point we just want to first establish the similarity. Once it's established, then we're able to draw our proportions. So the height of the tree is going to be proportional to the height of the stick, which is 2.4. And that proportion has to hold same the shadow of the tree and the shadow of the stick. Using my algebra skills, cross multiply, I've got 1.3 h is equal to 6.96. And then when you divide by 1.3 on each side, you'll find that the height of the tree is approximately 5.4. We're going to end up rounding that. 5.4 units. I don't have any units on this, so I'm going to assume it's meters or something.